Imagine you have spent all your life honing one skill. Let's say playing the guitar. You have sacrificed everything to be really, really good at it. You have no social skills, no friends, you have dropped out of school, but you can play the guitar like no one else. Then imagine one day, while you are riffing away, the guy next door, who is a surgeon, takes your guitar to try it out for the first time, and he was instantly better than you. Now, that's a very sad story, but it is exactly the impact that GPT model had on the industry. Because before GPT, we had to train out NLP models for very specific tasks. And after a lot of training, they were good, but only for that one task they were trained for. Not only the training was long because they needed a lot of labeled data, but the model crumbles the moment we try to ask it things it was not trained on. And then GPT dropped and was able not only to perform a wide variety of tasks, but it was able to outperform the models on that one thing they are really good at. But how are we able to move so fast? After reading the research paper for each of the GPT models, I have summarized how it was done and how the race is only getting started. In 2018, the paper Improving Language Understanding by Generative Pre-training was published by OpenAI. The paper reached two conclusions. A model can be trained in a semi-supervised way, meaning a huge chunk of the work was done without human supervision. The training was done in two stages. The first stage is learning a high-capacity language model on a large corpus of text. So this is unlabeled data and supervised learning. This is followed by a fine-tuning stage where we adapt the model to a discriminative task with labeled data. The goal is to find a good initialization point instead of modifying the supervised learning objective. I have explained in more detail how supervised and unsupervised training works in the previous video on how ChatGPT technically works. So, what data did they feed GPT-1 to train it? They used the books corpus dataset, containing over 7,000 unpublished books. It's important that the data is unpublished to help the model train on unseen data. And this dataset had large stretches of contiguous text, which helped the model learn large range dependencies. And the results were in. GPT-1 performed better than specifically trained supervised state-of-the-art models in 9 out of 12 tasks the model were compared on. And GPT-1 did two really amazing things that will shape the evolution of the GPT models. On some tasks, it was good at zero-shot performance. That means the model is presented with no examples to make it understand a task. Basically, if you can play a song on the piano without ever hearing it or seeing the notes, that is zero-shot performance. And number two, the model showcased the potential of pre-training and the realization that with larger datasets and more parameters, the models will improve greatly. And that's exactly what they did. 1 year later, in 2019, OpenAI published the paper Language Models Are Unsupervised Multitask Learners, a model that is 10 times larger than GPT-1. This research pushed what we thought was possible for zero-shot performance. We had already seen some zero-shot performance capability in the GPT-1 model, but this model was able to outperform 7 out of 8 state-of-the-art models in zero-shot setting. It was able to perform on data he has never seen before. It just understands the task based on the given instruction. And for the dataset used to train GPT-2, OpenAI used Reddit. They called it web text, over 8 million documents, 40 gigabytes of text. But how about the perplexity problem? Perplexity of a language model measures the degree of uncertainty of a language model when it generates a new token and its average over very long sequences. So the lower the perplexity, the better the language model. So what happens if they keep feeding it more and more data? Will it start achieving worse results? Well, it was the opposite actually. The more data the model had, the lower its perplexity. The paper described 4 models with different parameters: 117 million, 345, 762, and 1.5 billion parameters. The model with the highest numbers of parameters performed better on every downstream task. like reading comprehension, summarization, translation, and question answering. Here are some zero-shot results on many datasets. No training or fine-tuning was performed for any of these results. But in summarization, GPT-2 did not perform well. The research concluded that with an increase in the capacity of the model, the performance increased in log linear fashion across tasks, and the perplexity decreased with the increase in the number of parameters. So with that in mind, only one thing to do: drop more data into it, and I mean a lot more. If GPT-2 was 10 times bigger than GPT-1, GPT-3, with its 175 billion parameters, is 100 times larger than GPT-2. GPT-3 was OpenAI breakthrough language model. Even for the people working on it, they do not fully understand how it works. This model was able to generate long sequences of text, even long paragraphs, and they were so unique that it would trick the reader into thinking a human was behind the keyboard. For the GPT-3, they wanted a language model that everyone can use and one that does not require specific tuning. When compared to BERT, for example, it required a lot of fine-tuning to perform downstream tasks. With GPT-3, users can eliminate the fine-tuning step. The authors discovered that GPT-3 was really good at in-context learning. Here we can see the difference the number of parameters make when talking about in-context learning. And in-context learning just means teaching a program to do something with words by giving it some examples of how to do it. For example, if you wanted to write a summary of a text, you give it some text and their summaries before giving it a new text to summarize. It can use the examples to learn what a summary is and how to write one. So in-context learning can help the program do many different tasks without changing its structure or code. So instead of going the traditional way of fine-tuning a model, GPT-3 showed high performance in zero-shot, few-shot, and one-shot setting. In few-shot setting, the model is provided with a task description and a few labeled examples. In one-shot setting, the model is provided with exactly one example. And in zero-shot settings, as we saw, no example is provided. And the better the model, the better were its performance on each of these settings. And for the dataset they used for GPT-3, they took Common Crawl, WebText2, Book 1, Book 2, and Wikipedia, but each had a weight assigned to it. So the higher quality dataset were sampled more often for the training. GPT-3 surpassed all expectations, but the model showed some limitations. It was hallucinating at times in trying to write long sentences. Basically, it will lose all sense and coherence, but will sound confident in what it is proposing. And the obvious risk with a model this good is using it for fraudulent, scammy, or other unethical things. And a concern that a lot of media pointed out is that GPT is racist or sexist. But this is of course wrong. We can't be thinking of an LLM as a creature or a person. It only carries the biases of the language it was trained on. And it was trained on the internet. So there were a few things to improve, and the next version shook the entire industry. In the next video, we will cover GPT-4. I have read the research paper and there is no way to fit everything in this video or it will take way too long. GPT-4 is game-changing and as we speak, it is affecting a lot of lives. Thank you for watching and I will see you in the next one.